Okay, let's unpack this. We are diving deep into the world of 3D printing filaments where, well, looks are pretty much everything.
Yeah.
This is where the engineering goal kind of flips, doesn't it? We're
hmm
deliberately aiming for visual elegance, trying to hide those telltale signs that something came off an FDM printer.
That's a great way to put it.
Yeah.
And, for anyone who's got standard PLA down and wants to push things towards, say, photorealism or just really professional look,
Yeah.
you absolutely need to understand these specialized composite materials. Today, we're focusing on two big ones: Matte PLA, that master of hiding layers, and Wood PLA, which is all about that organic texture.
Right. And our mission here is to give you the quick, comprehensive rundown. We'll get into the engineering secrets, tackle those weird mechanical contradictions, especially with Matte PLA.
Oh, yeah, that's a tricky one.
And crucially, detail the hardware you must invest in for Wood PLA so you don't accidentally, break your machine trying to make something pretty.
Exactly. Let's kick off with Matte PLA. This is the filament that gives your prints that instant professional kind of glare-free finish.
Yeah, it's perfect for prototypes or like anything that's going to be photographed, right? But how does it actually do that? How does it hide the layers and kill the shine? Is it just a coating?
No, it's fundamental. It's baked right into the material.
Yeah.
Basically, Matte PLA is made by adding tiny, microscopic solid particles into the standard PLA base.
What kind of particles?
Usually things like silica, talc, sometimes even specific types of cornstarch, little inorganic fillers.
So it's a composite material then? Like concrete, but tiny.
Precisely.
Uh-huh.
And these little fillers, they act like light diffusers. Think about standard PLA light. Hits it, bounces off uniformly, gives you that gloss. With Matte PLA, the fillers scatter the light everywhere, randomly, to no gloss. But crucially, this scattering also kind of optically blurs the sharp edges between print layers.
Okay. That's why models look cleaner, less 3D printed.
Exactly. It minimizes that layered look significantly.
Makes sense. And beyond just looking good, I know it has a massive advantage for post-processing, for painting.
Oh, absolutely. That's one of its biggest practical pluses.
Yeah.
Because the surface isn't perfectly smooth, it has that texture from the fillers. It has this natural tooth or grip.
Right.
So if you plan to paint your part, primer and paint just stick so much better compared to smooth, glossy plastic. It can really cut down on the filling and sanding needed beforehand.
Saves a lot of finishing time then.
Huge amounts.
Okay, but here's where it gets confusing. The big debate around Matte PLA, mechanical strength.
Right.
Logically, adding impurities, these fillers should weaken it, shouldn't it? They get in the way of the plastic bonding properly.
Theoretically, yes, your intuition is spot on.
Yeah.
Those fillers can interrupt the polymer chains, disrupt layer bonding, create stress points,
Right.
leading to lower strength, maybe more brittleness.
Right.
And sometimes you see that in tests, like standard PLA might have a flexural strength of, say, 76 megapascals, while a matte version might only measure 53 MPa.
Okay, hold on. For someone listening who isn't an engineer, what does that drop from 76 to 53 actually mean for a printed part?
It means it's significantly less resistant to bending before it breaks or just permanently bends out of shape.
Yeah.
If you're making like a bracket or a clip that needs to hold weight,
Yeah.
that almost 30% drop could be the difference between it working fine and just snapping under load.
I see. I've seen test data suggesting the complete opposite, that some matte PLAs are actually stronger than the standard PLA from the same brand. How does that even work? It feels like a total contradiction.
It is the great paradox here, and context is key. So those MPLAs measure strength over an area, right?
Okay.
But other tests look at failure under a point load, measured in newtons. And in one specific test I saw, comparing filaments from the same brand, their Matte PLA actually withstood 41 newtons of force.
And the standard.
Standard PLA failed at 37 N, and even their PLA Plus was only 39 N. So
Oh, what's going on there? Is the filler somehow reinforcing it?
it's complicated. Could be a few things. Sometimes the base PLA used for the matte version is just a higher quality polymer blend to begin with. The fillers might also absorb a bit of impact energy, like tiny shock absorbers.
Yeah.
Or maybe the way matte filament cools leads to slightly better layer bonding in specific tests. Not straightforward.
So if the results are all over the place, weaker here, stronger there, just telling people to test the brand feels a bit like passing the buck, doesn't it? Can we give any general advice?
That's a fair point. I guess the general rule has to be cautious. You just can't assume anything about strength with Matte PLA.
Right.
It depends so much on the brand, the type of filler, how much filler. If you need a part to be structurally sound, you really have to test the specific spool you bought.
But for purely visual stuff.
Oh, absolutely fine. For models, prototypes for looks, photography parts, go for it.
Yeah.
The visual benefits are clear, and the strength variance probably won't matter.
And printing it. It's mostly like standard PLA settings-wise,
Mhm.
relatively easy on the hardware.
Yeah, compared to wood PLA, definitely. Settings are pretty standard. Nozzle around 190 to 230 Celsius, bed 50 to 70. The main issue sometimes reported is maybe slightly poorer bed adhesion. You might need to dial that in carefully.
And price?
Usually a little bit more than standard PLA, maybe 10–20% premium, something like that. Not drastically more expensive.
Okay. And one last thing, the environmental side.
Right. Those inorganic fillers, the silica or talc, it's definitely not suitable for industrial composting. So if sustainability is your top priority, you need pure PLA.
Good to know. Okay, that covers matte PLA, well, the professional look, the painting advantage, and that whole strength puzzle. Let's switch gears. If matte PLA is about hiding the plastic, wood PLA kind of does the opposite. It embraces being a composite to mimic something totally organic. Let's talk wood PLA, that authentic look and feel.
Yeah, wood PLA is a true composite. It's PLA mixed with actual fine wood dust or fibers, typically somewhere between, say, 15% and 30% wood by weight.
And they use different woods.
Oh, yeah. You see pine, bamboo, cedar, cork, even darker ones like ebony, giving different shades and slightly different textures.
And the smell.
Yeah.
That's a big part of it, isn't it? Does it really smell like wood when printing?
Incredibly so. It's one of its most distinct features. Instead of that usual warm plastic smell, you get this aroma, honestly, like a woodworking shop. It really changes the feel of the printing process.
Sounds amazing.
Yeah.
But that wood component brings some serious, non-negotiable hardware demands, right? This isn't just plug and play. You can actually damage your printer if you're not careful.
That is the absolute key warning for anyone thinking about wood PLA. Those wood particles, even as dust, are hard and abrasive.
Yeah.
As they get squeezed through the nozzle,
Yeah.
they act just like fine sandpaper. They will wear down a standard brass nozzle incredibly quickly. We're talking maybe just a few dozen hours of printing sometimes. It's not an if, it's a when.
Okay, so what are the immediate must-do hardware changes?
Number one, hardened steel nozzle.
Mm-hmm.
Non-negotiable. You need that abrasion resistance.
Light steel.
Number two, a wider nozzle diameter. Wood fibers can clump up, and they love to clog a standard 0.4 millimeter nozzle. You really want to go up to at least 0.5 millimeters, but honestly, 0.6 millimeters or even larger is safer. Gives the fibers more room to flow.
Okay, so hardened steel, wider diameter, that's an upfront cost, isn't it? A good hardened nozzle, maybe a different size. You're looking at what, $40, $60 maybe? Is the wood look worth that initial hit?
Well, it depends entirely on your goal. If you want that handcrafted look, or if you plan to sand and stain it like real wood afterwards, then yes, absolutely, it's worth it to protect your machine.
And if you don't upgrade?
You'll just be fighting constant clogs, potential extruder issues from back pressure, and you'll be replacing brass nozzles frequently anyway. The cost of getting that aesthetic is really about preventative maintenance here. Pay for the right nozzle now or pay more later.
Makes sense. So once you've got the hardware sorted, what about print settings? Anything special needed to get the best results?
Yeah, you definitely need to slow things down. We usually recommend printing slower, maybe in the 40 to 60 millimeters per second range.
Why slower?
It just reduces the pressure inside the nozzle, gives the wood composite more time to melt evenly and flow without jamming up.
Okay. And retraction. That's usually important for clean prints, but pulling fiber stuff back and forth sounds risky.
You absolutely hit the nail on the head there.
Mm-hmm.
Retraction can be a major source of clogs with wood PLA. The fibers can catch or get packed in the heat break.
So what do you do?
You often need to experiment. Try reducing the retraction distance a lot, or sometimes, if the model allows it, even turning retraction off completely. You might get a bit more stringing, but that's often better than a major clog you have to clear.
Right, trade-off. Now, what about that wood grain trick? How do you get the print to actually look like it has grain?
Yeah, that's a neat one. This is where you get a bit artistic. If your slicer software lets you vary the nozzle temperature during the print, say changing it by 5 or 10 degrees Celsius at different layers or heights, the plastic comes out slightly different colors. Hotter usually means a bit darker, almost like a slight scorch. So if you layer those temperature changes strategically, you can create subtle variations in color that mimic natural wood grain patterns.
Clever. Now, you mentioned it's got organic stuff in it. Does it soak up moisture like real wood too?
Absolutely. It's very hygroscopic. That means it just sucks moisture right out of the air like a sponge.
And that's bad for printing?
Really bad. Damp filament prints terribly. You get bubbles, stringing, poor layer adhesion makes the part brittle. So just like actual lumber, you must dry wood PLA before printing. Usually a few hours in a filament dryer at around 40–45 Celsius does the trick.
Okay, so keep it dry. Mechanically, we know it's generally weaker than pure PLA, not great for functional parts. But its real strength, maybe like matte PLA, is after printing, post-processing.
Yes, that's its superpower. Because it has wood fibers, it sands beautifully. Much easier and smoother than pure PLA, which can get gummy or melt if you sand too hard.
And staining.
That's the magic part. After sanding, the surface is porous because of the wood. It readily accepts common wood stains, oils, varnishes. They soak right in. You can make a 3D print look and even feel remarkably like real finished wood.
Okay, so if we tie this all together, matte PLA, wood PLA.
Yep.
What's the common thread for someone looking at these? What's the big trade-off?
Well, what's really interesting is that consistently comes back to this. Getting these specific high-end looks always involves a compromise. You're consciously choosing form over, well, raw function or ease of use.
Right. For matte PLA, you're dealing with that confusing strength data, maybe a slight price bump.
Yeah, maybe 20% more than bulk PLA sometimes.
Yeah.
And you have to be mindful of which brand you're getting if strength matters at all.
Whereas wood PLA, that demands actual hardware changes up front, the nozzle situation.
Definitely. Hardened steel, wider diameter. Plus, you need to be way more careful with print settings, manage moisture. It's a higher investment, both initially and in terms of ongoing effort. And the material itself is pricier, often 50% or more above standard PLA.
The payoff is the look.
Exactly. If your main goal is the visual impact, hiding layers, killing reflections with matte, or getting that organic wood texture, then these specialized filaments are honestly unmatched. They let you create parts that just don't look like typical 3D prints.
So we've dug into the professional finish and paint readiness of matte PLA and the organic vibe but necessary hardware for wood PLA. It really highlights how choosing these advanced materials is often a direct trade-off, isn't it? Beauty versus brawn, almost.
Yeah, a bit of a zero-sum game sometimes.
Right.
Once you've mastered basic PLA, the choice isn't just about color anymore.
So the final question for you, the listener, becomes, how much are you really willing to invest? We're talking hardware, drying time, maybe giving up some mechanical strength, all to make a 3D print look completely unlike a 3D print.
And are you okay knowing that the very thing giving you that perfect wood look might be slowly grinding away your nozzle? That's the real cost of aesthetic perfection here.